Until now, you've seen me use the expression selector to modify various properties of our text lines, and I'll keep using them for animation also. Apart from making me look smart and cool, the expression selector gives you precise control over your text. The text engine in After Effects is not any different from the MoGraph system. Imagine the text elements, characters, words, or lines as clones in MoGraph. In both cases, we have an effector, or animator, for position, scale, rotation, color, etc., and a falloff that controls how much that effector is applied to the clones, or text elements. The range selector in After Effects is closer in functionality to the step effector in Cinema 4D, but the expression selector gives you the same amount of control that Python and formula effectors have. It may take time to get used to. That's why I dedicated a separate video to the animation sector of my tutorial. Turn the border layers visibility off for now. We'll set up the animation for the main text first. Add a position animator to our main text, rename it Position Offset, and delete the range selector. Set the position values for X and Y. Keep in mind that these values represent the maximum offset from the current location of each text element. This value will remain constant for all text lines throughout the layer's duration. What will vary with every line will be the falloff amount. Add an expression selector and let's edit the amount property expression. What we will need are 4 variables: anim for animation, off for offset, count, and ID for index. Count and ID are easy. They are the built-in variables text total and text index. We'll subtract 1 from the text index to make it start counting from 0. Anim is a global value ranging from 0 to 1. Off represents the offset of each text element from the previous one, also expressed in percentage. We'll want the animation to happen in the first 25 frames of the layer's duration, so let's normalize this segment of time into a 0 to 1 range. Type linear, time is represented in seconds, in point plus 1, 0, 1. Set the offset value to 0.25 for the moment. We'll return to them both later. The main formula for the animation is as follows: anim time count minus ID. The result should be fitted in a range from 0 to 100%. So cut this part of the code and type linear, open parentheses, paste the code here, and continue typing the range start and end, 0 and 100. Slide the timeline to test the setup. All is working, only in reverse. In a proper revealing animation, the lines should start coming from the outside into the screen. That's easily fixable. Just swap the range start and end values in the linear function. At the moment, every line starts moving when the previous one has already stopped. That's exactly like the default range selector behavior. But we chose the expression selector to have control, right? Let's tweak the code further. Multiply both count and ID by the offset value and test again. Now each text line animation appears to blend with the animation of the previous. But something is still not right. The animation seems to stop before the last line takes its place. Add 1 minus offset to the product of count and offset. There you go. If you want to tweak the blending between lines, adjust the offset value. You can also change the interval during which the animation takes place by choosing another frame for anim in. but I'll show you something better. Instead of having to hard-code the values in the expression field by expanding the amount property of the expression selector, we'll use a layer marker to store the animation length in frames. In the comments field, type data equals curly braces anim colon 25 comma off column 0.25 close curly braces. This is a special type of data called JavaScript object literal. It stores a list of comma-separated pairs of names and values. You can reference those values from the expressions quite easily, using the names before the colon character. You can also use the expression control effects, but for values that don't have keyframes, this is also a good alternative. Now let's reference those values from the expression. In the first line, for the animation variable, replace the hard-coded value 1 with this bit of code: eval, open parentheses, marker.key1.comment, close parentheses. The eval function executes the string in the comment field as JavaScript code and returns the result, which is the object we created earlier. Continue typing .anim to get just the animation value from that object. We entered 25 frames for the animation duration, so we need to convert it to time in seconds to be able to edit correctly to the endpoint. Cut this part of the code, type frames to time, open parentheses, and paste it as an argument. We will also need to change the hard-coded offset value with this bit of code: eval marker.key1.comment.off. In plain English, this reads: evaluate the text in the comment field on the first marker of this layer, and from the object literal that it returns, get the value of the attribute called offset. Hit enter and test the result. Even if you drag the layer itself around the timeline, the animation starts based on its endpoint. Now let's add the position value also to our marker. Double-click on it, and before the anim attribute, type pause, colon, open square bracket, -500, 0, close square brackets, and a comma. This attribute represents a position vector. Alt-click on the position properties of the position offset animator and type eval marker.key1.comment.pause. This way we can tweak the position offset without having to search through many properties of the layer. You can leave it here if you like, but wouldn't it be great if we automated an out animation based on the layer's length? It's not that hard. We only need to tweak some of the lines we have already written. First, let's add an attribute for the out animation. Open the layer's marker window and add a new line of code: duration out, column 50, comma. Also, rename the anim attribute to duration in for consistency. The expression returns an error because it doesn't recognize an anim attribute anymore. Rename it to duration in instead. Also rename the anim variable to anim in and replace it anywhere else down the code. Duplicate this line of code and rename the variable to anim out. The main structure will remain unchanged except for the input min and max range. Remember that the last frames of our text layer are the ones that serve as reference to our borders. So, the end of our animout will come before this interval of frames, which is as long as the total number of lines. So, replace the max value of the input range with out point minus frames to time text total. Copy this part of the expression and replace the min value of the input range. Now add to the text total value the duration out interval of frames by typing eval marker key 1 dot comment dot duration out. Assign the last line of code to a variable. The name doesn't really matter. This is only for clarity. I'll call it simply A1. This represents the in animation. Duplicate this line and rename the variable to A2. This will represent the animation out. So replace the anim_in argument name with anim_out. Also, reverse the output range. In the end, add A1 and A2 together. This animates the fall-off weight from 0 to 1 and back to 0. We could have just added the two expressions together. I just put an extra step in the middle for clarity. Preview the composition to test what we've done so far. Tweak the values in the marker window at your heart's content. Another variant of the in and out transition is to have the lines go out in the opposite direction they came in. Instead of adding A2 to A1, subtract it. Test the result. You can experiment also by changing the interpolation type from linear to ease. I find it more pleasing to the eye. Now the text animates in and out of the screen, but this introduces a new little problem. With the text gone from the screen during the last frames of the layer's duration, so are the reference frames for the borders. To remedy this, let's make sure that the separate text lines stay in place during that interval. Go to the position property, cut the expression code, and type outPoint minus time is greater than frames to time inside of parentheses text.sourceText.split \r.length plus 1. Question mark. Paste the code here and continue typing column a vector 0, 0. This is basically the same expression we used earlier when we compared the countdown value against the total number of lines, only written differently since we don't have access to the built-in variables such as text total and text index that the expression effector offers. And that's it. Move the timeline bar around and see that after the lines animate out of the screen on the frames immediately after, each line appears on the screen separately. It's incredibly easy to apply this animation to the borders too. It's just a matter of copying and pasting the position offset animator into it. After Effects will complain because there is no marker present on this layer. So, expand the position offset animator, find in the code all the instances of the word marker, and set it to reference the marker on the parent layer with this bit of code in front of them. This layer dot parent dot. Preview the comp. To not see the last frames after the animation has finished, you can either adjust the out point of the work area or simply add an expression to the opacity property of both text and border layers with this code. OutPoint minus time greater than frames to time text.sourceText.split \r dot length +1 question mark 100 colon 0. We've made use of the backward counter I explained in the first part and compare it to the number of lines. There are as many frames at the end of the layer's duration that serve as a reference as there are lines of text. If that counter value is less than the number of lines, the layer becomes invisible. Now you don't have to worry about those last frames at the end. You can duplicate the layers and chain them together if you have a long speech with multiple lines of text. Trim the layer's length, update the text, change the animation in and out lengths, etc. If you don't want the titles to leave the screen, set the out duration value to 0. In the last part, I'll show you how I set up this project. The soccer field is a separate layer. It's a pre-comp, in fact, with one shape layer containing many groups of shapes, animated traditionally with keyframes. But that is not the focus of my video. I've drawn an open mask on this layer and made each player's name follow the points of that mask. The players' names can be manually typed or easily copied from a spreadsheet file, and you can also tweak their designated positions on the field by manipulating the points of this mask. The mask itself is 2D, although the layer it might be 3D. That makes it easier to precisely position its points around using the keyboard. I'll show you how to attach each line of text to one mask point and have it follow the field as if it were parented to it. You see that I can move and rotate the pitch layer around, and the names of the players will continue following their targets to the pixel. Hide the border layer for the moment. Let's work on the main text first. Disable the position offset animator, add another position animator, and remove the default range selector. Set the position value to the width and height of the composition. You can set any value here as long as it covers the whole area screen. Again, this vector represents how far we can offset each line in any direction, so it sets the maximum distance overall. It's the expression selector that will determine the direction and the actual offset for each text line. It returns an individual vector for each line with values ranging from -100% to 100%. That percentage will be based on the coordinates of the mask points. It may sound scary, but I'll try to explain it as simply as possible in a way that I hope will make sense. First, we need a handle to the layer that holds the mask. Type mask layer equals thisComp.layer soccer field. To place the text at the points of the mask, type pause equals mask layer dot mask 1 dot mask path dot points, and inside square brackets text index -1. We travel through the hierarchy of the layer containing the mask, get the first mask, whose index is 1, select the mask path property, and then use the points function, which returns an array of vectors for the points that make up that mask. Now, based on the index number of each text line, We match them to the corresponding position of each point on the mask. Indexing for the text elements starts at 1, whereas the mask points start counting from 0. So we subtract 1 from the text index. Continue by normalizing x and y components of that position vector to range from 100 to 100%. Type x equals linear, pos 0, negative width, negative 100, 100. And y equals linear, pos 1 for the y component. Input range is from negative height to height of the composition, and output range is again negative 100 to 100%. In the end, we return a vector xy. Hit enter. Something happened, but it's a mess. Let's see. First, zero out the leading amount between the lines for the main text layer. Still a mess? Select one of the points of the mask and try moving it around. The text follows the movement, but it's offset awkwardly. That's because of the different coordinate systems that the mask point and the text lines have. Mask point positions are calculated about the layer's origin where the mask is drawn. That origin is the top left corner of the layer. That's the 0, 0 coordinate. For the text elements instead, the coordinate system is based on that layer's anchor point. You can zero out the position of the main text layer so that it matches the origin of the field layer, and that seems to work, but not really. Even if you parent the main text layer to the field, when you move and rotate the parent around, something seems wrong. The scene does not work quite like the example. I'll show you how to do this the right way. For this to work, we need to convert the mask point positions from the soccer field layer's local coordinate to global coordinate. That is the comp coordinate. That's not enough though. The next step is to convert those positions from comp coordinate to the main text local coordinate system, which is based on the anchor point. That way we are truly parenting each text line to the corresponding point of the mask shape. It's called space transformations. Let me show you two functions that After Effects expressions offer to do space transformations. Create a new line and from the expressions preset menu, choose a layer, space transformation to comp. Create yet another line and select from comp in that same menu of presets. The time argument is optional, so we erase it. By default, it works on every frame. The first function converts the coordinate system from a layer's local space to global comp space. Being a layer function means it needs a layer to work on. We're converting the mask point's position to comp space, so we choose the mask layer to operate on. The function takes a vector as an argument, so we cut the point position expression from the previous line of code and paste it inside the parentheses. The next function, fromComp, converts coordinates from composition space to a layer space. It also takes a vector as an argument, cut the previous line of code, which returned a comp space vector, and paste it inside the parentheses. The layer whose local space we need to convert this comp space vector to is this layer. After this chain of conversions, cut this line of code and assign it to the pos variable. Now everything should work as it's supposed to. The text lines seem pinned to their position on the field, no matter how we move, rotate, or scale it. And the beauty of it is that even the position offset animator works on top of it. Enable its eye icon and test it yourself. If you don't want the text to transition out of the screen, simply edit the marker properties and set the duration out to 0. The setup works fine if there are fewer points on the mask than the players' names, but it will pop up an error if you type more names. To avoid confusion, I'll make still one more adjustment to the code. Surround the text index -1 part in parentheses and enter this bit of code after it, inside the square brackets too. Modulo mask layer dot mask 1 dot mask path dot points dot length. The modulo operator makes sure that even if you enter more names than points, those new lines jump to the positions of the starting points of the mask. That way you can easily see when you need to add more points to the mask. Before copying this last animator to the border layer, make sure it only affects the text during the first segment when it's displayed as a block. Cut the width-height code and type outPoint minus time is greater than frames to time text dot source text dot split \r dot length +1 ? Paste the code here and continue typing : open square brackets 0 0 close square brackets. Again, in plain English this means if the countdown value is greater than the number of lines converted from frames to time, the maximum position offset will be width height. Else, there will be no offset. This step is necessary so we do not double transform the borders later on. Now copy-paste the animator to the border. Everything should work as expected. Move the points of the mask around and test it yourself. Keep in mind that the position animators are accumulative, so you can enable the position offset animator and it will work on top of the mask follower. You can enable or disable any one of the animators and check the result yourself. Play around and keyframe your version of the in animation for the soccer field. Also, have the names of the players come from any direction you wish. The position of the players will always follow the position of the mask points, even if for any reason you parent any of the layers to another one. And that's all. I hope you have learned one or two new things about the use of expressions in After Effects. I decided to share this video for free, detailing every step. But if you want to support the making of other videos like this, I would appreciate it very much if you bought the scene files from Gumroad for a symbolic price of $5. You're not obligated, of course, but it would mean a lot to me. Picking a good subject, finding ways to illustrate the concept, and recording a video tutorial is no easy task. So, every bit of contribution on your part would mean that this is not all in vain. And as always, if you liked the video, please share the knowledge.